Okay guys, now we want to look at a uniform distribution. So let's do this using an example. Here we're told that the seller announced that the highest bid above 10,000 will be accepted, and the random variable x is uniformly distributed between 10,000 and 15,000. Suppose you bid 12,000, what is the probability that your bid will be accepted? So before we start any uniform distribution problem, we have to find f of x. So that's the most important step in terms of uniform distribution, finding f of x. And there's a formula for that, and that formula is f of x equals 1 divided by b minus a. Now what is a, what is b? Well, a is always the smaller number and b is the larger number. So back to this example, we know that a has to be 10,000 and b is 15,000. And so 1 over b minus a gives us this formula. My suggestion is to leave this number as a fraction. So leave it as 1 over 5,000. That's what it works out to in this case. And let's go on to the next step. One thing we want to do is to write out the probability statement. So right here, this is what we're looking for. What's the probability that x is between 10,000 and 12,000? In terms of this problem, this is when you know you win, because the competitor is represented by random variable x. And so this is what the competitor is doing. So if they do this, then you're going to win because you're going to be at 12,000, which is higher than them. And so we want to find the probability of this occurring. So the uniform distribution is used to represent what we call a continuous random variable. And whenever we have a continuous random variable, we're going to use the area under the curve as the probability. So that's what we have in this case. So the probability, again, is the same as the area under the curve. So next, always sketch the graph. In this case, it's uniform, and that's a rectangle. And so we want to sketch this rectangle, and this is what it looks like. So we have the f of x gives us the height of the rectangle, which is 1 over 5,000. So that's the height right here. That's how high this graph is. Then we have a, then we have b. Now notice a and b for a given problem are going to stay the same. So a is 10,000, b is 15,000. Now we want to find the area between 10,000 and 12,000. So the first thing we do is to shade the area that we want. And then we go into the area of a rectangle. And the area of a rectangle is the base times the height. So what is the base? It's 12,000 minus 10,000. So what we're looking for here is just the distance on your graph for the x value. So what's the distance when we go from what's the distance when we go from here to here? It's 12 minus 10, which is 2,000. And so what we're going to have is this 2,000 times 1 over 5,000, which gives us 2,000 divided by 5,000, or 0.4. Now you want to give the decimal, right? So you keep the fraction for f of x, but when you get to your final answer, you give it as a decimal, so 0.4. Next, we look at part B, where we're going to bid 14,000. And again, we want to see the probability that our bid will be accepted. So let's write the probability statement out again. We see the probability that x is between 10 and 14,000. And we do a sketch. And here the height is again 1 over 5,000. Notice a remains the same at 10,000, b remains the same at 15,000. Now our x value is 14,000, and we shade the area right here. And you can see that even just shading it gives me an idea of what value to expect in the end, right? It's going to be a value larger than 0.5. And when we do our calculation, we see that the area is actually 0.8. So the probability is 0.8. And that's the answer. Part C wants us to find the amount you should bid to maximize the probability of getting the property. In this case, the probability ranges between 0 and 1 as a rule. So the maximum probability you can get is 1. So for probability equal 1, we see that the bid would have to be 15,000. And this is because the area under the curve between 10 and 15,000 would be 1. Okay, so your answer here would be 15,000 in terms of a bid. In part D, what is the average the competitor will bid? So what's the average value of X? Now this is a formula. And this formula is A plus B over 2. So we see that right here. So it would be A plus B, do this part first, then divide everything by 2. So our answer here should be 12,500. A common mistake here is for students to pull out in their calculator 10 plus 15 divided by 2. And so they're not dividing the entire numerator by 2, right? It needs to be summing up top first, then dividing everything by 2. So make sure that's how you're approaching this thing. Okay, part E says, suppose you know that someone is willing to pay you 16,000 for this property. Would you consider bidding less than the amount in part C? That means less than the 15,000 in part C. So what we're going to look at in this case are the expected profit. So we're going to look at the expected profit, and one way to calculate that is to look at the probability of winning times the profit if you win. Okay, so this is somewhat similar to what we looked at in chapter 5 when we looked at the expected value of X, and then that was equal to the sum of X times f of X. It's very similar to this. In this case, this is the f of X in terms of the probability of winning, and this would be the value you get if you do win. And so we want to start with the 15,000 because that's the one the question asked about. So when we look at the probability of winning, if you bid 15,000, we see that's a 1. It's a 100% chance that you win if you bid 15,000, because that's what we got from part C. So with that, when we do our calculation of the expected profit, we get 1 times the profit, which is the amount that you're gonna sell the property for minus the amount that you bid. So it's 1,000 profit that you get in this case. Let's see what happens when you bid 14,000. In this case, the probability, as we saw earlier, is 0.8 times the amount you profit, which is 2,000, and the final answer is 16, this should be 1,000, 16,000. No, that's fine. This should be 2,000 times 0.8, which is 1,600, sorry. All right, the next one is at 13,000. What's the expected profit? This is 0.6. We haven't done this one yet, but if you do the probability for 13,000, you'll get 0.6. So you could do that as a practice, right? So do it similar to how we did part A and part B. So we have 0.6 times 3,000, which gives us 1,800. And then we do it for 12, and we saw for 12 earlier that it was 0.4 probability of winning. We multiply that by the amount you win, and it would be 1,600 in the end. So we see that the answer here is yes, you would bid less than 15,000. And how much would you bid? Probably 13,000 if you work these numbers out, because this is maximizing your expected profit, the 13,000. So your optimal bid in this case would be 13,000. So that's it. That's what we got.